Hello, everyone. My name is David Uday. I'm a UC Davis undergraduate student studying material science engineering. I am here today giving you a presentation on a project pitch for reducing our environmental impact. But first, I want to tell you a little bit about this. I am both a student, but also a passionate social activist. I care about both the environment and improving social justice for communities that have been marginalized or discredited. As part of this, I want to make sure that my engineering research and field of study reflects this. I want to make sure that social consciousness is a part of improving the effectiveness of our technology. Specifically, I want to look at how humans are impacted by things such as mining practices, our reliance on technology that often comes at the cost of inhumane labor practices, along with pivoting towards carbon neutrality to stop the rampage of climate change from destroying particularly vulnerable peoples in developing countries. The main reason that I want to look at this is because I'm very interested in nuclear engineering, which is why I've chosen to look at nuclear reactor control rods as a means of both reducing our carbon footprint to reduce human suffering while simultaneously looking at how to effectively improve our means of carbon neutral energy production with reactors we already have commissioned. In particular, the reactors we have commissioned and the future fourth generation reactors rely on control rods to regulate the fission process. These rods are made of materials that are not fissile and are also made, in some cases, of materials that will be highly radioactive for the foreseeable future. And the failure of these rods will result in massive human and environmental suffering. So it is imperative that as material engineers, we make sure that they are constructed of the most appropriate materials. Specifically, the traits that we were looking for in these control rods is a couple of key engineering traits. Very, very high melting temperatures, glass transition temperatures, ductile transition temperatures, and all other phase change temperatures that are above the operating temperatures of the fission reactor. We also want to make sure that these rods are not going to have any mechanical or corrosive failures during their lifetime, because again, that would be incredibly bad for both the environment and the people around them. We also want to make sure that these control rods are, most importantly, constructed materials that are capable of stopping the neutrons from going and continuing the fission process. To do this, I want to look at papers and resources that are currently researching how to make reactors safer through advancements in control rod technology. Thank you. I hope you guys have found this an enlightening presentation.